it's emitting radio waves that your radio is picking up. And they've got a fantastic thing at New Mexico Tech. It's called the Lightning Mapping Array, and they've got sensors, a whole bunch of them, spread over many kilometers. And they take every little spark triggers some of the sensors. And they use multiple detections of a given spark. So here's a spark, and many sensors see it, and they can locate the spark, in where it was exactly in the cloud. And they get thousands of these, and they can map the flow of charge, the flow of the current through the cloud. So they see the branching into the charge layers, they see all the current flowing, they see it attached to ground. They've got some beautiful graphics and movies of charge motions through the clouds. And that's how they did this study, where they saw that it was starting in a very small region, because they're literally mapping every little spark that comes off of the lightning. At the lab, we tend to use satellites because we're testing technology for satellites. So we look at the radio waves in the light using a satellite, and what I worked on was Forte, and we've had other follow-ons since then. And then there's some exotics. And so I just want to close by giving some of the exotic things that come off of lightning. X-rays come off of lightning. It was suggested in the 1920s that this should happen. And it was first observed, I think, in the early 2000s or late 90s by Ken Eck, who used to be at the lab and is now at New Mexico Tech. It was then also observed by the lightning team in Florida. New Mexico and Florida have a lot of lightning. New Mexico and Florida have lightning teams. So it's now been observed many times, and it's starting to look like most, possibly all events seem to give off some X-rays. And it comes specifically from that attachment, the attachment process. It's not coming from every little step. It's coming from that instant when the connection is made and you get a huge current flow. Gamma rays have also been detected now. These are typically detected from satellites because gamma rays, they penetrate a certain distance, but you have to be pretty close. So if it's near the top of the atmosphere, your best bet is for a satellite to see it. So gamma ray flashes come from lightning as well. There's a kind of lightning discharge called a narrow bipolar event, and that name means nothing except how the data look, because we didn't know what the hell we were looking at. So narrow bipolar events now seem to be related to these initiating things. They happen before the rest of the flash. They don't give off optical light. There's another mystery. Why? It's a huge freaking current. They're the most powerful radio emitters in lightning, and they give off no light. I have no idea why. And they're special. They aren't simply the powerful end of the distribution. They aren't simply the most powerful lightning. There's something special about them. In a number of ways, they don't look anything like other lightning. And then there's something very cool. If you go on the wiki page and look up sprites, in addition to the little fairy creatures, you'll get sprites are these energetic discharges that they lob cold plasma, ionized cold plasma, up into the upper atmosphere, and then you see not hot continuum white radiation. You don't see the white light. You see the red, which I'm not sure if that's nitrogen or oxygen. It's some specific line, and it's a transmission line from some molecule in the atmosphere. And they look like they were first seen in the 1880s by people, and people started going, "Holy cow, what was that?" And everyone said they were crazy. They weren't actually photographed until 1989. So 100 years later, because you have to be in the right place at the right time, and you kind of have to be like high on a mountainside and looking out over the atmosphere to get a really good view. But the astronauts get to see them pretty often, and they look like great big red blobs with blue tendrils that come down. Sometimes they look just like jellyfish. They have like a halo, kind of a ring around them. And there's all sorts of exotics and variants. There's jets that are like, they come from a little lower and they're just blue. There's all sorts of really cool phenomena, but you have to, it's really serendipitous if you can see them. And so those are observed a lot from satellites and from the space station and stuff like that. And then here's just one cute little fact. And I went too long, but here's the last little fact and then I'm done. So the charge that moves in a lightning strike reaches like 100 million volts. And if you had 100 million volts, it's lowering a lot of charge into the ground. So if you wanted, you could use that to create a current that would light every house in Santa Fe for like a minute or two. So it's not useful, but it's cool. And that's it.
Well, I've already worked a while. So now we're going to open it up for questions and answers and discussions. And
I have a quick question. So, oh, sorry, you go ahead.
Anyone.
Oh, thank you. So in the storms that don't have ice, do you think it could be like particles like of dust or maybe even bacteria? Because they move along in clouds.
So some of the other models for how the storm electrifies are things like during thunderstorm activity, you get positive charge in the atmosphere low, and so some of the thoughts are that it's getting the winds from the convective cell are lofting charges and charged particles, dust or whatever, high into the atmosphere. So it could be a lofting. It could also be other macro particles, rain or snow, but I think the microphysics of how they exchange charge isn't as well understood. So I think it could be a number of things, and there's many different possibilities. But yeah, it could be a lofting of something charged near the ground, like dust or whatever.
Because I've heard pollen can be like shredded after thunderstorms, and your allergies could be worse. That's what they said at the allergy office. So I don't know how.
Well, here.
So I just wanted to make sure that I was understanding this correctly. You said that some of the spark comes off the ground, and you can connect. Am I understanding correctly when you say that you can connect the spark to a storm that's like 20 kilometers away?
So when lightning is trying to find its way to the ground,
Yeah.
it sounds very slow when I do it like this.
Yeah.
And what's actually happening is that over the course of maybe 10 microseconds, it'll finally find its way to the ground. Okay, or maybe if it's building up for 100 microseconds and then finally finds it. So it's very fast. And like on the order of microseconds before it actually reaches the ground, streamers come up to meet it. So a fast camera would start to see glow, light, optical light in a channel here, coming to meet the light coming down. And then when they touch, you get a great big flash. Okay? So now that is connected to the cloud.
Okay.
And the cloud goes for 20 or 30 kilometers, and those charge layers are there. So just because maybe all the lightning seems to be over the Jemez, if the clouds are anywhere close to here, there's no reason it won't find a channel right down to me.
Okay.
See? And so if you think that you're near a thunderstorm, it's not a good place to be. So
Is there have you found any connection to where on the
So there's a whole field of study for this, and
Yeah.
specifically it's lightning protection, so they're trying to protect buildings, because if it hits your house, I don't know if you've noticed, your phone lines go dead or whatever, so it damages everything in the house. It can damage big buildings in cities, lightning hits planes all the time, it hits cars. So lightning protection's a big deal, and the best thing I think that people have found largely is to try and tease it, put a lightning rod on top of your building and then drain all the current to ground so it doesn't go into the building. And that's sort of, that's Benjamin Franklin technology, although maybe a little better. They literally designed it into buildings. Now, big buildings, they have it discharge into the rebar and stuff that are, and it comes down into the ground, so people don't even see it.
But like naturally occurring?
So if you're not somewhere that has a lightning protection system built into it, it'll tend to go for the high stuff because that's the easiest place for it to get to, right?
Yeah.
And there are pictures. There's some fantastic pictures on the web. The lightning channel is coming down here, and then it goes almost horizontally to meet some tree or something over here. So it tends to look for the highest point, but it doesn't have to.
So like if you're a human standing with a bunch of trees around you, because you're out there like checking a water sample.
Yeah.